Okay, today we are going to continue our investigation of motion with acceleration, and we're going to talk about a special type of acceleration. It's the acceleration due to gravity. So you can cross this out, this main idea from the G-Lab. We did not do any special lab for gravity, so you can just cross that out. But gravity, as you may know, is caused by the mass of the Earth. So the mass of the Earth will cause anything that's dropped or thrown into the air to experience an acceleration. And in the G-Lab, we actually measured that acceleration, but we didn't have time for it this year. So I'm just going to tell you what that value of that acceleration. So we call the acceleration due to gravity g, lowercase g, it's always lowercase. And g is equal to 9.8 meters per second, or 9.8 meters per second squared, okay? Now, as I'm sure you are aware, when you drop something, it always falls down. So think about what happens when you drop something. Not only does it fall down, but it speeds up on the way down. So the acceleration due to gravity is always down. So the acceleration would be equal to negative g. We're always going to take down as the negative direction and up as the positive direction. So what that's saying is that if I drop something, and let's talk about what happens when I drop something. If I drop something, if something is released from rest, that means that its initial velocity is equal to 0. So what the acceleration due to gravity is telling me, since it's 9.8 meters per second squared, is that after 1 second of time, if I drop something, that object has gained 9.8 meters per second of velocity. After 2 seconds, it's gained 9.8 meters per second times 2, or 19.6 meters per second. Okay? So when we drop something, we release it from rest, its initial velocity is 0, and it's going to gain velocity at a rate of 9.8 meters per second per second. Now, the acceleration due to gravity is always 100% of the time, down. We get to determine if down is positive or negative. I will always assume that down is negative, and that therefore the acceleration of anything that is being dropped or thrown is going to be negative 9.8 meters per second squared. Now let's think about what happens when it hits the ground, okay? You might be thinking that when an object hits the ground after it's been dropped, that its final velocity will be 0. In fact, that is not true. Okay, when we drop something, its final velocity is not 0. Its final velocity is actually very large. What you're thinking about is that, and why you think it's probably 0, is because when we drop something, eventually it does come to rest. But it only does so because it's under the influence of hitting the floor or the ground. The ground is what causes it to stop. So all these problems that we're going to do in the next couple of minutes here, we're going to assume that the instant it hits the ground, whatever the object is that it hits the ground, it still has a large velocity. It has not come to rest because it's not still falling. It's in the process of hitting the ground, okay? So we're going to do some example problems now. So what I'm going to ask you to do is take out your calculator. So pause the video if you need to. Take out your calculator, and we're going to try a bunch of these problems together. And we're going to do these problems just as the way that we've done the rest of the problems in this unit. The first thing we're going to do is we're going to list out all of our variables. So for this problem, which I haven't even read yet, and I don't even need to because I know I have to list out my variables, I'm going to list those out. And then let's go ahead and read this. A ball is dropped from a height of 15 meters. How much does it spend in the air? And what is the velocity of the ball when it reaches the ground? Now, a couple of things. This problem has 2 hidden variables. The first one is that the object is dropped. And we already talked about that. If an object is dropped, we know its initial velocity is 0. In addition, I know its acceleration. Its acceleration is 9.8 meters per second squared. So right away, because I know this object was dropped, I'm going to plug in my initial velocity is 0. My my acceleration is 9.8 meters per second squared, and it says it's dropped from a height of 15 meters. Now I bet that you are tempted to put that delta x as 15 meters, and you'd almost be right. But remember, we said that down is the negative direction. So because the ball is going down, we're dropping it, we know that that delta x has to be negative. Now I know my final velocity is a question mark, my time is a question mark. So now I can go ahead and I can figure out which equation. Remember, I have three kinematics equations. I have my position equation, my acceleration equation, and my timeless equation. I have to find time and I have to find the final velocity. So I'm going to go ahead and I'm going to start with my position equation. Maybe I get someplace and maybe I don't. It's okay if I don't. I know I just pick another equation. There's my position equation, so I'm going to plug in what I know. Negative 15 meters is equal to, well, VI is just 0, so this whole term goes away. So negative 15 meters is equal to 1/2 times negative 9.8 meters per second squared times time squared. I can go ahead and I can simplify that a little bit. I can multiply that 1/2 by negative 9.8, and I know that that's negative 4.9. Oops, I forgot my units there. Don't want to do that. Meters per second squared times time squared. And now I know I can divide by negative 4.9 meters per second squared on each side, whatever. I remember my algebra rules. Whatever I do on one side, I have to do on the other. Okay. So go ahead and do that on your calculator, all right? And you will find that t squared then is equal to, those negatives cancel out, and it's equal to 3.06 seconds squared, which is great, but that's not t. Remember, I have to take the square root. And I get that t is equal to 1.75 seconds. Go ahead and pause the video and make sure you get the same thing. If you don't, check your algebra, okay? That's great. I now know the time that it takes, right? And I can go ahead and highlight that. But then now I want to find the final velocity. So I'm going to have to pick a different equation. This time I'm going to pick my acceleration equation. V final is V initial plus A times T. So V final is that initial velocity, which I know is 0, plus negative 9.8 meters per second squared times the time, which we figured out above was 1.75 seconds. So my final velocity is equal to, if you plug that into your calculator, negative 17.15 meters per second. And I can go ahead and highlight that. And I have found both answers to the problem. Now notice how that velocity is a negative number, okay? That's not too surprising because I know when I drop something, it starts moving in the negative direction. And we know that if you're moving in the negative direction, you must have a negative velocity. So that answer makes sense to me. I'm glad that I came up with a negative number. The only variable that's listed here that will never be negative is time. You can't have negative time. That doesn't make any sense. Acceleration can be negative. Final and initial velocity can be negative, and displacement can be negative, but time can never be negative. All right, let's try another problem here. Let's see. A ball is thrown upwards on a flat ground with an initial velocity of 25 meters per second. How fast is it moving after 2 seconds? So again, I'm going to list out all of my variables, delta x, v initial, v final, a, and t. This time, instead of being dropped, the ball is thrown upwards with an initial velocity of 25 meters per second. So my initial velocity of 25 meters per second is going to be positive because the ball is going up. We want to know how fast is it moving after 2 seconds. So I know my time is 2 seconds. I don't know how far it's gone, but I do know the acceleration, negative 9.8 meters per second squared. I know 3 things, so that's all I need to know to solve for the other 2. Since they're asking me how fast, I would like to find an equation that has v final in it. And I remember my acceleration equation, and my acceleration equation says that v final is v initial plus a times t. So I can plug that in. V final is v initial, which is 25 meters per second, plus my acceleration, which is negative, so I can just go minus 9.8 meters per second squared times the time, which is 2.0 seconds. I can plug that into my calculator, and I can find that the final velocity at that time at 2 seconds is 5.4 meters per second. Notice that that's a positive number. So I know that at 2 seconds, the ball is still going up. That's what that tells me. If the velocity, the final velocity is positive, I know the ball is still going up. Now they ask another question. How fast is it moving at 3.5 seconds? So I have to pretty much start the problem over. Not entirely, but a lot of it I have to start over. I still know my time. This time is 3.5 seconds. I still know my acceleration, even though it's thrown up. And this is what a lot of people get confused by. Well, how can an acceleration be negative if the ball is going up? Well, think about it. Have you ever released something and had it go up? Have you ever dropped something and had it go up? No, of course not. The acceleration due to gravity is always down. It's always negative. So that's why I'm always going to have that negative sign there. So now I know my initial velocity is still that 25 meters per second. I don't know my v final, and I don't know my delta x. So I'm going to use my acceleration equation again. V final is v initial plus a times t. And I'm going to get the v final is that 25 meters per second minus 9.8 meters per second squared times the time of 3.5 seconds. And when I do that, I'm going to find that my final velocity is negative, this time, negative 9.3 meters per second. Notice this negative sign right here. I know that now, if I have a negative velocity, I must have a ball that's going in the opposite direction. It's going down now. So that tells me something very interesting. That tells me that sometime between 2 seconds and 3.5 seconds, the ball changed directions. And if it changed directions, that means that its velocity must have been 0 at some point. Because if you're going to change directions, you have to stop and turn around. There's no other way to change directions. So that gives me a hint as to how I'm going to do this next problem. So let's take a look at our next problem. Our next problem says, well, how much time did it take to reach the top of the path? Well, our big hint here is that at the top of the path, the velocity has to be 0. So now I'm going to go ahead and I'm going to list my variables again, delta x, vi, vf, a, and t. I know that the initial velocity is still this 25 meters per second. I know the final velocity now. It must be 0 because if it's at the top of its path, the final velocity has to be 0. And I know the acceleration must be 9.8 meters per second squared. I don't know the time, and I don't know how far up it went. So I'm going to go ahead and I'm going to use my acceleration equation again. And I'm going to put in, okay, my v final is 0. My initial velocity is 25 meters per second. My acceleration is still 9.8 meters per second squared, and I don't know the time. So I can go ahead, I can do a little algebra there. I have to subtract the 25 from each side. Then I have to divide by the 9.8 meters per second squared. And if I do all that correctly, I'm going to find a time of 2.55 seconds. That's the time it takes for that object to go from the ground to the top of its flight. Okay? This next question is very interesting. How much time does it take to reach the ground again? This is a really important concept. So let's see what we're going to do here. We're going to have to know how far the ball actually falls. And let's do this in part C. Okay, so in part C, we're going to find what delta x is. We're going to find how high up it went. So I'm going to say that delta x is my initial velocity times my time plus 1/2 at squared. I already know my initial velocity, I know my acceleration, and I found my time in the first part of problem C. So I can plug in what I know. Delta x is 25 meters per second times 2.55 seconds minus 1/2 times 9.8 meters per second squared times that 2.55 seconds, and I have to square all of that. People love to forget to square that time there. When I do that and I plug that into my calculator, and I would suggest you pause the video right here and you check to see what you get in your calculator. So pause it and then come back. And then hopefully you got that your delta x was 31.88 meters. Maybe you rounded differently, that's fine. So that means that the ball went up 31.88 meters. I got a positive number there because the ball went up. So that makes sense that I got a positive number. So now let's look at part D again. Now we want to know how much time does it take to come back down. So I know my delta x. We're going to talk about that in a second. I know my v initial. I don't know my v final, and I don't know the time. You might be tempted to put that that delta x is 31.88 meters. But remember, it's going down now. So that needs to be a negative. Think about what our initial velocity is if it's going from the top of its path to the ground. Well, our final velocity was 0 for part C. So that means that our initial velocity for part D has to be 0. I don't know my final velocity when it hits the ground. I do know it's not 0. I do know the acceleration as well. It's always, if for something that's thrown or dropped, I know it's that negative 9.8 meters per second squared. But I don't know the time, and that's what I'm trying to find. So let's take a look here. I can probably use my position equation. Delta x is the initial velocity times the time plus 1/2 at squared. So I get negative 31.88 meters is equal to, well, that initial velocity is 0, so that's gone. 1/2 times negative 9.8 meters per second squared times time squared. So go ahead, pause the video again, and see what you get for time. All right, hopefully you got that the time is, big surprise, exactly the same as the time to go up. So it turns out that the time it takes for the object to go up to its maximum height is exactly the time it takes for the object to come back down to where it started. It's symmetrical. So if it takes 2.55 seconds to go up, it takes 2.55 seconds to go down. So the total time it would spend in the air then is the addition of those. So it's twice 2.55. I hope that makes sense. All right, here's what I would like you to do now. Go ahead and pause the video and try problems 5 and 6. Okay, try those on your own. And then I'm going to put the key here. I'm just going to show the answer and you check your answer. If you don't get what I got, then you should ask me in class. Okay? Good luck with those problems. All right, for number 5, you should have gotten that the final velocity of the meatball is negative 3.96 meters per second. If you got a positive number, you're forgetting something very simple from math class. And here's what you're forgetting. I'll bet you know what the square root of 4 is. I'll bet you know that it's 2. But did you also know that it could be negative 2 as well? Every time we take the square root of a number, we get 2 results. We get plus or minus. So the result of the equation that you got for the final velocity could have been the positive or the negative root. When we take the square root, we call the result the root. You chose the positive root. Why did you choose that? Because you've been pretty well trained by your math teachers that the positive root is probably the right one because you're used to finding what is the length of the side of this triangle. In physics, we'll be finding other things as well. So you have to decide, do I need to take the positive root here or the negative root? In this case, I know it's the negative root because I know that the meatball is going down. And I know that anytime something's going down, that velocity has to be negative. So if you got positive 3.96, you didn't choose the correct root. You've got to go back and say, oh, yes, of course I know that it's negative because it's a negative velocity because it's going in the negative direction. If you got something else besides 3.96, then check your math, check your arithmetic, check your algebra. Make sure that you didn't make a silly mistake, okay? All right, if you got that, go on to problem 6 and see what you get for the answer for problem 6. All right, for problem 6 for the time, I got that the time it takes to get to the top of its flight is 3.27 seconds. That should be a positive number. Okay, so we know that our final velocity was 0. Our initial was 32 meters per second, and our acceleration was negative 9.8 meters per second squared. So I know that the time always has to be positive, and that did bear out in the equation. I chose the acceleration equation. Once you do that, you can go back and use your position equation and solve for delta x. I got a delta x of 52.2 meters. So 52.2 meters is how high that object went into the air. That's it. Great job taking the notes today.